Okay, well, welcome to lesson 1 for our flip project for Algebra 2. If you recall yesterday, we looked at quadratic functions and what we call the general form of quadratic function. Y equal ax squared plus bx plus c. And we talked a little bit about the graphs of these, and that's something that we're going to examine today. Today we're going to learn how to graph transformations of what I call the basic quadratic or the basic parabola. And again, yesterday we looked at y equal or f of x equal x squared. And we sketched a graph using the TIs, and we got something much prettier than this. And I apologize, I did this freehand. My parabolas honestly kind of are, well, they're very lame. But it looked roughly like this. It passed through the point 1, 1, and 2, 4, and let's see, 3, 9, etc., etc. Now, if you recall, back a couple chapters ago, we began looking at if we have a basic function that we know a graph of, we can sketch transformations of that basic function, and we developed this table here. If I have the basic function plus a number, it would shift that basic function up c units, f of x minus a number down, replacing x with x plus c, shifted it to the left. It's kind of counterintuitive. You'd think plus would go to the right, but it actually went to the left. F of x minus c shifted it to the right. When we had a constant multiplied by our function, what that did, that magnified or shrunk. It stretched or shrank, whichever, the function. Because what we were doing was multiplying the y coordinates by that constant. Then if we had a negative in front of the function, that was taking the negative of all the y coordinates. So all those y coordinates became negative. It opened down, or excuse me, it reflected it over the x-axis. All right, so what we're going to use as our basic function now is f of x equal x squared, and here's our graph. So let's look at a function h of x h of x is negative 1/2 x squared plus 3. This is a transformation of x squared. What I want you to do right now, pause for a second and see if you can, pause the tape, see if you can identify the transformations. Now, looking at this, I see 3 transformations going on here. First of all, the plus 3. Well, if I ignore the negative 1/2, just look at the plus 3. That is a shift up. I'm adding 3 to x squared. So I've got to shift up 3 units. Then, looking at this, I'm going to ignore this negative. Just look at the 1/2. Well, what is that doing? That is multiplying my function by a constant, 1/2. And since that number is less than 1, if you recall, that's going to multiply all the y coordinates by half. It shrinks it. So we have a shrink of 1/2. And then finally, the negative here. If I ignore the 1/2 and the 3, I have the negative of the function. What that's going to do, that's my last case here, that is going to reflect my graph over the x-axis. So I've got a reflection. So, now that I've identified the transformations, what I want to do is sketch my function, h of x. Now, we're going to start with this basic function, And we're going to use the transformations here, but there's a certain order in which we do those. If you recall, I don't know how long ago, a few weeks ago, talked about athletes have a certain order in which they do things. When an athlete goes out, a football player, a basketball player goes out to practice, first thing they do is they stretch. So they do their stretches. Now before they start practicing, before they start running around, next thing they're going to do is they're going to reflect on what it is they're going to do that day. Coach comes around and tells them, this is what we're going to be doing this day. So then they reflect. Then the last thing they do, they start moving, they start practicing, they start shifting. Athletes do the same thing. We do stretches, then we reflect, and then we do our shifts. So, let's see. First thing I've got a stretch, which is actually a shrink, but that's a form of a stretch. I'm going to shrink the graph by half. And the way I do this isn't a terribly accurate way to graph, but it's a great way to get a quick graph. So I'm going to shrink every y coordinate by half. So I'm just going to pick a couple. 1 is now going to be 1/2. 2, 4 is now going to be at 2, 2. I shrink the y coordinates. And so this, now I've got a couple of them. And of course, this is going to be symmetric over here. So it's going to look like that. All right? Now, next thing that we're going to do is we are going to reflect. So I'm going to reflect this over the x-axis. Try and keep the same shape, not very well, but close enough. And then the next thing we're going to do is our shift. I've got to shift up 3 units. So I'm going to take this, I take this point here, and what do we call that point? That point in this case where the function stops increasing, starts decreasing. Anyone? Say it again. That's right. That's the vertex. So I'm going to take that vertex and I'm going to shift them up 1, 2, 3 units. And again, keeping the same shape. So this is my graph of h of x. And this was my graph of my original function f of x. Probably should have labeled that to begin with. But now I can see here is my final graph h of x. Here's my original graph f of x. One thing that we're going to be interested in making note of is what is the vertex, and does the parabola open upwards or downwards? Does it have reach a highest point or a lowest point? So my vertex is a point, well, it's up here at 0, 3. And this thing, this parabola, opens downward. And that's going to tell us something. We've got a name for that when it opens downward. Or actually, it tells us something about the vertex. We say that that has reached a maximum point because it is the highest y-coordinate on the graph. So we say that this vertex here is a maximum. Likewise, if the parabola had opened upwards, if that were a lowest point, we'd call that a minimum. Okay? So after we sketch this, we want to make note of what the vertex is. Is it a maximum or a minimum? Does it open upward or downward? Cool, cool? All right. Let's try another one here. Excuse me for that. Let's do P of x equal, let's go x plus 3 squared minus 1. Now, what I'd like for you to do, pause the video here and see if you can identify the transformations and sketch the transformation from the basic function. Identify the vertex, maximum or minimum. Does the parabola open upward or downward? While you're doing that, I'll continue on, or actually now you've finished and started the tape again. It's not a tape, that shows my age. Starting out here with my basic function, y equal x squared. Now, what transformations are going on here? I see two going on. I've got a plus 3 and I've got a minus 1. So that tells me, let's see, that plus 3, that's an x plus 3. That's on the inside. It is being squared. I've replaced x with x plus 3. It's called a composition. That is a shift to the left 3 units. Then I've got the minus 1 on the outside. That is a shift down 1 unit. And I don't see any other transformations going on here. Anything multiplied out in front, well, it's a 1. The 1 doesn't do anything. So let's see. I don't have any stretches, don't have any reflections, so I go right away to my shifts. Doesn't matter which one you do first. So I'm going to shift to left 3. 1, 2, 3, and down 1. And trying to hold the same shape. Again, these are not going to be super graphs, not real accurate like you'd get on your TIs. But the purpose of this is to be able to get a quick sketch of the graph, to get an idea of what it looks like, where it's located, and be able to identify key features. And the key features here, first of all, are vertex. Well, I shifted to the left 3 and down 1. So my vertex is at -3, -1. All right? Now, is this a minimum? Is the vertex a minimum, or is it a maximum? I feel like Steve on Blue's Clues. Anyone? A clue? Yeah, it opens or upwards. It reaches the lowest point, so we would call that a minimum. And I'm just going to put min. And just a note here. We say that the y-coordinate, that's the function's value. That is the minimum value of the function, -1. That's the lowest value the function f of x reaches. It occurs at x equal -3. The x-coordinate just tells me where on the graph am I looking. The y-coordinate gives me the actual function value. And of course we can see this opens upwards. All right. Now, by looking at these transformations, this yields another form of a quadratic. And that is called vertex form. And vertex form looks like this. Now, y equal a times quantity x minus h squared plus k. This shows all possible transformations that could be occurring to y equal x squared. Looking at this, a is a constant that's multiplied out front. A is going to stretch it or shrink it. Now, technically, I should say the absolute value of A, because if A is negative, then that's another transformation occurring here. So I'm going to put absolute value of A. If A is positive, I've got a positive value here. That tells me something about the shape of the parabola. If A is positive, which way is it going to open? That's right. It's going to open up. And if A is negative, I've got a negative value out in front here. He's going to open down. Now, we have a very fun way to remember that. If A is positive, if you're positive, you're a very happy person. And if you're a happy person, what do you do a lot? You smile, don't you? And then if you're a negative person, if you're a Debbie Downer, what do? You frown. It opens down. Isn't that fun? Thought you'd like that. Now, the last thing is vertex. Where do you see the vertex in vertex form? Hopefully, it's the horizontal and the vertical shift. Now, notice I have x minus h here. If I have x minus something on the inside, my fourth case there, that's a shift to the right. So if it's x minus, then it's going to be a positive h, whatever I see there, x minus 2, it would be a positive 2. And for k, well, that's going to be the vertical shift up or down, so it's going to be k, the y-coordinate of the vertex. All right? Now, that's quite a bit to think about. We've got two forms now, general form, and we've got vertex form. Vertex form is very nice because it allows me to identify very quickly what the vertex is, whether it's opening up or down, a maximum or a minimum. Of course, I could always just think of the basic function and what transformations are occurring, but if I recognize vertex form, I can jump right to there. Now, I've got a few problems that I'd like for you to try. So, for tomorrow, I would like for you to take these two functions. G of x is equal to 3 times x plus 2 squared. And h of x equal to negative x minus a half squared plus a fourth. And for those two, what I would like for you to do is sketch those by transformations. Okay, so these, I want you to sketch make sure you identify the vertex and whether it's a max or a min. Cool, cool? And also, I would like for you to think about this function. why is this not a transformation of x squared? Riddle me that, Batman. So these two functions, I would like for you to sketch by transformations like we did today. Identify the vertex, whether it's a max or a min. Of course, I'll tell you opens up or down. And then this one, I want you to think about this and have something you can write down and tell me, why is this not a transformation of x squared? So, until tomorrow night, this is Mr. Clark signing off.